Okay, so I want to start with multidimensional arrays today. The arrays we have talked about up until now are one-dimensional. They just are a linear collection of variables. Now we're going to talk about multidimensional arrays, and to make things not too abrupt, let's start with two-dimensional arrays. The way two-dimensional arrays are used in C and C++ is actually very much like one-dimensional arrays of one-dimensional arrays. And so if you need a two-dimensional array and you know how to build one-dimensional arrays, now you can just form a one-dimensional array of one-dimensional arrays, and you're going to have a two-dimensional array. Is that clear? Yeah? Let's say you know how to form one-dimensional arrays. Form a lot of one-dimensional arrays, put them in a one-dimensional array, and you have a two-dimensional array. And that's the basic idea. We write a two-dimensional array like this, for example. So here we're declaring a two-dimensional array, and that two-dimensional array has 30 elements in the one dimension and 100 elements in the other dimension. How do you read this? Well, the way to read this is to think about it like this. I mean, you don't really put those parentheses in there, but what you're saying is, you're saying that there is something that has 100 chars, right? If you would put just an A here, you would be declaring an array of 100 characters. Yeah? Now what you're doing with this is you're saying all these 30 array variables with index from 0 up to 29, each and every one of them is an array of 100 chars. Hey, Gando, could you turn that one off? I mean, the AC. Thank you. Much better. Much quieter. So, every one of those index positions from 0 up to 29 is going to be an array of 100 chars. And of course, there are very many ways how we can imagine this arranged. And one way that we can think of is that these here form the rows and these here form the columns. Yeah, that's just one pretty, how should I say, plausible arrangement. But we also have to understand that in memory, they're not arranged in two dimensions. They're not arranged like they are on the paper, on the plane. In memory, they would be arranged like this. If you remember what I told you about arrays, well, page is an array of 30 elements. So what the compiler does, the compiler chooses a starting location, and for sake of something different, let's start at address 5000. It chooses a location in memory where the page array starts, and of course somewhere it ends, and there are 30 elements in the page array. There are 30 elements, and each and every one of them is of the base type. And the base type in this case is not just char. The base type in this case is a char of 100 elements, a char array of 100 elements. So each and every one of those in here has 100 chars in turn. Yeah? So my arrangement in memory is completely linear. It's as if I want to view this page as having 30 rows, and each row with 100 columns, then it is as if I wander along the first row, and I place every character that I see in memory, and then I wander along the second row, and I place every character that I see in memory, and so on and so forth. Yeah? Yeah. So one way to visualize it is that it is arranged like this, where 0, 0 would be up here, 0, 99 would be over there, and then whatever 5, 50 would be here, and so on. But you have to understand that that's just one way of laying this out. Yeah? Or put another way, if you have some two-dimensional arrangement that happens to look a bit different, you could still map it onto an array with 30 and 100. For example, if you had 30 columns and 100 rows, you could still store it in here. Yeah? You'd be rotating it, so to speak, but it still could fit in there. You could still use, not saying that I have an example where this makes particular sense, but theoretically you could do that.
So that just means there's 30 arrays and that has the size of 100. Makes sense.
Yeah. When we pass an array, a one-dimensional array, to a function, the entire array, we did not have to put the dimension of the array within the square brackets when we passed the array. Why was that? Well, because we had the base type that that the parameter carried, the array parameter carries the base type. So just from the starting address that the function would receive, and then the index that we would use to index into the array, and the knowledge of the base type, the compiler could locate the exact position in memory where the index variable would have to be. The situation is a bit different when we use two-dimensional arrays. The reason is that if you look at the page array, then the page array is really a one-dimensional array. But if the page array is a one-dimensional array of 30 elements, then char 100 elements, a char array of 100 elements, that together is the base type of every element. So yes, I can pass that array without giving this dimension, but since this dimension here is part of the base type of the elements, I have to provide this dimension. So when we have a function like the one on the slide that's called display line, well, no, that's display line, display page, the second one. If you look there, this second square bracket that has the 100 in it, that needs to be there because the char array of 100 elements, that is the base type of the elements in the page array, and that's why it has to be we can also view this from another perspective, and it might clarify it a bit more. When inside a function like display page, I want to do something within maybe two nested loops. I want to write something like cout insert. Is it called page there? Yeah. Page 566. Let's say. In reality, within that nested loop, I would really insert into cout page I, j, something like that. But let's say the values of the value of I is now 5 and the value of j is 66, for the sake of simplicity. Okay, now what needs to happen? Well, the correct location within the page array needs to be determined. So page 5. Well, I wiped this out. I should have left this on the whiteboard. Page 5. Well, how large is a step? How far for every increase of this index do I have to go forward from the starting address? How much do I need to go forward from the starting address for every increase by 1 in this index? So for every one index here more, how far do I have to jump ahead?
66.
No.
To get to each index. So to get to 66, it would be about 566.
No. What I have to know what the size is, what the declared size is there for every chunk.
Oh, okay, right. That makes sense.
And then within the last chunk, I have to go 66 forward. That's right.
Right.
But only in the last chunk.
Right.
But I have to know the chunk size.
So if
Yeah?
it's, oh, right.
So if I would not pass this 100 in the second square bracket, if I would not pass that, then how would the compiler know what the second dimension is? And therefore, how large one of those chunks is that we need to go forward.
So that's why it's important to initialize that.
Yeah?
first.
So that's another way to look at it. That's another reason or another way to look at it to see why we have to put this the second dimension. By the way, any subsequent dimension. If I would have a 3-dimensional array,
You have to put the third
I would
one.
have a 1-dimensional array where every element of the array is a 2-dimensional array, and we already know how to form 2-dimensional arrays as 1-dimensional arrays of 1-dimensional arrays. So it's just a staged application of the same principle. Yeah, we just reiterate that same principle, but in the same fashion, I could only leave the first square bracket empty because the other 2 square brackets of a 3-dimensional array would be part of the base type of the uppermost array, uppermost 1-dimensional array. Okay. So now we're going to look at an example, a grading program that program maintains records for a class, and they're stored in a 2-dimensional array. We have a class with only 4 students here in this example, and only 3 quizzes. Can you believe that? And we have a grade array, and so that grade array is declared like this. Where we have a line. If we view this as the line, as I said, this is arbitrary, but let's view this as the lines. So we have 4 lines, every line with 3 columns. Okay, so we want to do is we want to compute averages. So let's say we want the average for every quiz over all the students, and we also want the average per student over all the quizzes. So we need two arrays. If we view this grade array as a 4 by 3 array, then we want a 4-element one-dimensional array for the student averages. Average. And we want a 3-element array for the quiz averages. Yeah. Okay, so let's look at this program. Oh, that's so small. Okay, so if you look at this slide 791, then you will see that we have functions here, compute st AVE, compute quiz AVE, display, and they're given here together with their preconditions and their postconditions. And the main function declares the two-dimensional array, and it declares the two one-dimensional arrays for the averages that I showed right there. And then it calls this the computation of the average, those two functions, and then it calls the function to display. So let's look at the with a broken lamp, that's really difficult. Okay, so let's look at the compute st AVE here. And you will see there's two nested loops. There's an outer loop and an inner loop. And that's clear. If you imagine what compute st AVE needs to do, it is supposed to go over, is it going over all the students or over all the quizzes? Yeah, okay, it's supposed to go over all the students. So for every student, it is supposed to compute that student's average across all the quizzes. So eventually we want to go over all the students, but for every student that we pick, we first want to go over all the quizzes, determining the average over all the quizzes for that student, saving it into that student average array, and then proceeding to the next student and doing the same there. So the outer loop goes over all the students, and the inner loop for every student picked, for every student that's selected by the outer loop, the inner loop goes over all the quizzes. Yeah? So that's a very typical way of working with two-dimensional arrays. Go over, for example, all the rows, and within every row go over all the columns. And as we will see in a moment in compute quiz average, we want to do the opposite. For every quiz, we want to pick the quiz or fix the quiz, select the quiz, and then for that quiz go over all the students. So there we use the same array, we just process it in a different order. Instead of holding on to a student while we go over all the quizzes for that student, in the other function we hold on to one quiz while we go over all the student numbers, looking at that individual quiz. Okay, so that's what you see here with this outer loop, going over all the student numbers. And here they have chosen to let the student numbers run from 1 up to an inclusive number students. The only reason or the only justification for this here is that they think of students in terms of numbered students starting at 1. They don't think about the students as index positions in the array starting at 0 and going up to some value. We think of them as students, numbered students, where the number of the students starts at 1. As I said before, if you have a program that very often uses the value of a variable in interaction with a human, then it's very likely that you would prefer this way, because we don't normally think of people as the 0th person. We think of the first and the second and the third. And then you'd do it exactly like this. You'd have the index running from 1 up to an inclusive number of students, and then whenever you use that variable for indexing purposes, you have to remember to subtract 1. Otherwise, of course, you'd make a mistake. Okay, so the second, the outer loop sets the sum, a local variable sum, to 0, and then for the inner loop it goes over all the quiz numbers, and it sums the grade entry in the two-dimensional array at the position stnum minus 1, quiznum minus 1, sums that number into the sum, and when that inner loop completes, sum contains the sum of the quiz scores for student number stnum. So after the inner loop, we have summed up all the quiz entries for one student, and then we set stave, the average array, at the corresponding position for that student to the average of the quizzes. And if you look at compute quiz AVE, it's, so to speak, the dual. The only thing that's different here is the order of the loops, and of course the array into which we store the results. So here we go over, we have the outer loop running over quiznum from 1 up to an inclusive number of quizzes. Again, we have a local variable sum that's initialized to 0, and then we have an inner loop that goes over all the students. Again, we have we store the corresponding grade entry, add the corresponding grade entry into the sum, and by the time we finish the inner loop, we have the sum of all student scores on one particular quiz, and then we can set the corresponding position in the quiz AVE array to the average of the quizzes for all this particular quiz for all the students. Okay, back and back, and here. Okay, so who of you thinks that you know how to write code that will fill an array declared, like it says there on the slide, declared as int a 4, 5, fill that array with numbers, with 5 numbers per line and 4 lines typed at the keyboard. And so my user wants to input something like this. Yeah? 4 lines, 5 numbers each. Cin, yeah, of course, that's at the core. But where does the Cin extract into?
Into what array? Into that array?
Into that array, exactly, yes. But at what position? What index positions?
J and I. Put it in a loop.
J and I, you say?
Yeah, and then you can put it in a loop so that it just.
J and I, and you want to put it in a loop.
Yep.
You can put j equals 0, I equals 0.
Right here or there?
Up, over.
But then if I do that, then there are 0. What does that help me?
Well,
put
since
it
we
in the
already have int, we already know how big the array is. Start the column and the row at 0, and every cn is gonna first fill the I, and once we've done with the
Wait,
5
that's
spaces,
it.
then we do j.
Do you want us to like fill it up by just typing in a number and then it assigns it, or do you want us to give a set amount of numbers and then just flood it into the
Yeah. We will have these 20 array elements, and we want to provide the 20 numbers, for example, like this. And what you write, the source code that you tell me now, is supposed to fill up the entire array.
automatically without having to like, let's say, press 1 enter, 2 enter, that kind of thing? Like
Well, you're gonna have to put a few spaces and new lines in there, yes.
Oh, okay, no, I just realized never mind, nothing else. Because if you want to automate it,
Isn't that it?
we can put
No.
all that numbers.
Is there
in.
something
If this would extract one number into position 0, 0 of the array.
And not 0, 1, 2 to 0, 1, and 3
No,
to
no, no.
0.
What you're doing here, you're setting this to 0, you're setting this to 0, then you're extracting into at that position that's stored in that variable, that's a 0, 0. So you're extracting into any 0, 0.
Yeah, we need a loop.
Yes, exactly. We need a loop.
We need a loop.
That's very good.
I said it.
Mm,
We need a loop. What kind of loop do we need?
a for loop
For
or a
loop.
while loop.
For loop does it. Okay, so let me put a for loop here. So over which value is the for loop iterate?
Zero. Wait, what do you mean by that?
Well, tell me
What
what
we
you
should
want to
put
put in those 3 parts
okay.
of the for loop.
Can we have two?
The first one we
two-
can leave blank.
Yes, we can. Yeah, we can leave that blank.
The second one,
For as long as I is not less than.
something
Where's on
is
mine?
not
Yeah.
less than 20, if I'm not mistaken.
No.
Something is still less
Because I think we can
than
put
20.
a loop in
Because
a
we
loop.
need 20 inputs, right?
Francis.
A loop in a loop, so we can have.
We can have a loop in a loop in a loop. We can have 2 loops, one nested within the other. Just like we just did with that grade example, right?
Yeah.
We had a loop within a loop.
Right. So.
We can apply that here.
What we can do for the first loop would be for the bigger one, which is the 4, and then the loop on the inside would be the 5.
Okay, so here you would say less than 4,
Yes.
and then you'd have another loop,
That's less
Or-
than 5.
whatever,
Yeah, it would-
whatever,
Yeah.
and here with less than 5.
So the second one will be I, and the first one will be J.
The second one would be I, yes, because of the way you chose
Yeah.
these here, and the first one would be J. Exactly. Exactly. And of course, this needs to be indented. This is
Yes.
inside the
Yes.
loop.
Then we can put
This-
all the I equals 0 and the j equals
What about
0
that?
inside the for loops.
Yeah, you could do that.
If you're really lazy
Yeah.
too.
But I don't want to do that now because I would have to wipe and rewrite.
Oh.
And if you're really lazy, you can just put all those numbers into an array, and then instead of doing cin, you just do array.
Yeah, but what if I need a different set of numbers
That's
the next
exactly
time I'm running?
that's the problem.
Okay, so that's good. That takes care of chapter 7. And I will need to